In this video, I'm going to explain about midpoint and angle bisector and how those come up in geometry. So every line segment has a midpoint. A midpoint, of all the points on the line segment, it's the one that cuts it into two equal congruent segments. So there's only one midpoint in a line segment. Imagine this line segment was length 10. That would make each of these pieces 5. Now here's an angle. Let's say it's 50 degrees. So a midpoint is a point. But an angle bisector, that's not a point. An angle bisector is going to be a line segment or a ray or a line. I'm going to draw it as a ray. And it basically slices the angle. Let's call this F here. It slices the angle into two congruent smaller angles. In this case, they'd be 25 degrees each. Now, a concept related to midpoint. Oh, so if this one was a ray or a segment or a line, the main thing is that it goes through the vertex of the angle that's being bisected. Now, we have angle bisector. There's also something called segment bisector. A segment bisector is kind of like an angle bisector in that it's a line, but it cuts through at the midpoint. So in this picture, we would say CD bisects segment AB. And if we're told we have a segment bisector, then the points where they cross, we can conclude M is the midpoint. And then we could even, once we know it's the midpoint, we can say that AM is congruent to MB. So if you see in your proofs, given that M is a midpoint, you can jump straight to saying AM is congruent to MB. And on the regions, they'd be fine if you wrote definition of midpoint. And conversely, if you're given a picture and they tell you that you have a line segment and there's a point on it so that AM is congruent to MB, you can make the conclusion that M is the midpoint of AB. And you could write definition of midpoint for that also. In this picture, it's given that DF is the angle bisector of CDE, so you can make the conclusion that CDF is congruent to EDF, and you can just say definition of angle bisector. And I could change this question around a little. Instead of telling you it's an angle bisector, I can tell you that the two angles are congruent with the two pieces, and you can make the conclusion that DF is, we could even say just bisects angle CDE, definition of angle bisector. So these have the same reason, definition of angle bisector, but in one of them, you're being told it's an angle bisector and proving something about the angles, and the other one, you're being told something about the angles and using that to prove that it's an angle bisector. In this picture, we're told that CD bisects AB at E. And eventually, we're going to be able to then say that AE is congruent to EB, but it actually takes a couple of steps. It's going to take 2 extra steps besides the given. So I have given AB at E. That's given. And even though you want to kind of jump to say AE is congruent to EB, we can't quite say it yet, because we can't say this unless we know that E is the midpoint. So we have to say in step 2, E is midpoint of AB. And for that, you could say definition of segment bisector. a segment bisector goes through the midpoint. Now you can say AE is congruent to EB, definition of midpoint. So you can't jump straight to step 3. Finally, there's one more thing I want to show you. This is an algebra thing first. So if you're given the 2x equals 10, we could jump to say x is equal to 5. And we could say division of both sides, division property, kind of like we have an addition property and a subtraction property. But we could also say specifically for this one that halves of equals are equal. And I show you that because here's a question where that's a geometry question where that's going to get used. In this picture, there's 3 givens. One is that M is the midpoint of AB. And from that, we can conclude that AM is congruent to MB. The second given is that N is the midpoint of CD, so CN is congruent to ND. And those are things that we're going to say. AM is congruent to MB, and CN is congruent to ND. That's all because of, definition of midpoint. But we're going to be able to do a little bit more because we're given another given. We're also told that AB is congruent to CD, meaning this whole line segment from here to here is congruent to this whole line segment. So imagine they're both 10. Well, of course, AM and BM are 5, and CN and ND would be 5 then. So all 4 things are equal to each other. And we are going to be able to say that. AM is congruent to CN, is congruent to MB, is congruent to ND. Those are all going to be equal to each other. But the reason we're going to say is what we did with algebra from before. We can just say halves of equals are equal. Or you could say division property. That works also. But we can't just jump to this without giving a reason. And it's not transitive property because we know AM is congruent to MB and that CN is congruent to ND, but those congruences don't have anything in common. So we can't say transitive. So we say halves. We take the fact that AB is congruent to CD. If I were to put numbers here, 1, 2, 3, 4, I would say it was step 3. It was step 3 that I used because it was mainly step 3 that I used to at least say this part. Since AB is congruent to CD, halves of each of them says that AB is congruent to CN, but they're all equal because of the midpoint situation here also. Here's a place where that midpoint thing might be used in a proof. We're trying to prove that DM is congruent to CN. Now the given is that DA is congruent to BC and that M is the midpoint of AB, not of DC, although it might end up being that also. So what we can say is that AM is congruent to MB, definition of midpoint. Then these pieces together need to equal these 2 pieces together, which is what they're asking. So our final step is going to be to say DA or AD plus AM is congruent, see I'm adding these together, to BC plus MB, or said another way, that DM, those 2 things combined, is congruent to CM, those 2 things combined. So addition property. And we could even go one more step. They didn't ask us to, but we could. We can then say M is the midpoint of DC. It was given M was the midpoint of AB, but now that I've shown that DM is congruent to MC, I can say M is the midpoint of DC, definition of midpoint. So before, I used the fact that it was a midpoint to conclude that these two pieces were congruent. Here, we're using the fact that these two pieces are congruent to conclude that it's a midpoint, but we can write the same reason, definition of midpoint.